Right, so here we go. I think this is video 4 now that we're busy creating. So what we've looked at in the past videos, part of this micro topic or macro topic, if you wish, is we had a look at the IP address structure. We've looked at how to understand binary and how those notations work. We've then discussed class-full IP addresses, and now we're going to start diving into the idea of what is a classless IP address. What does that mean? Now, to jolt your memories, in case it's been a while since you watched the previous video, and if you haven't watched the previous videos, please do yourself a favor and go have a look at those first. Everything will make more sense if it's done in the correct order. Now, if you have seen the previous videos, great, then let's remind you of a few things about class-full addresses. We know that there's class A, B, and C, and we know that based on the first octet, that actually defines what the subnet mask will be. So a class A has that subnet mask, a class B has that subnet mask, and a class C has that one. Now, something I could actually add into this, which I didn't when I made the first video, but bear in mind we can use the slash values, as I'd mentioned in previous videos. That would be a /8. In this case over here, this would be a /16. And in this case over here, this would be a /24. Right? And that now gives us the 3 different classes that we're looking at. Now, this is fine if we want to use class-full IP addresses. Classless was really designed because we ran out of IP addresses. Now, one thing you'll notice about IP addresses, the more you learn about them, the more you realize how many mistakes we've made over the years with them. And it was literally not long after their first release that suddenly we went, whoops, we're going to run out of these things. And the reason for it is fundamentally, a IP address is 32-bit number, right, in total. It's 8 bits, 4 octets, 32 bits all in all. If we take power of 2 to the power of 32 bits, so 2 to the power of 32, gives us 4.3, it's rounded up, 4.3 billion IP addresses. That's every single IP address that can exist in IPv4. Last I checked, population of this planet's around 7 billion. And again, last I checked, I probably consume about 100 of those IP addresses by myself. Now, this is, again, where another topic's going to come in, which is the difference between private and public IP addresses. But that was also created because we realized that 4.3 billion IP addresses wasn't going to be enough. So we had to come up with clever ways to reuse addresses. We had to come up with ways for DHCP, for example, to give you an IP address to use temporarily. And then when you're done with it, you give it back to us so we can allocate it to somebody else. That allowed us to reuse IP addresses. We came up with concepts like NAT, Network Address Translation. We came up with classless IP addresses, which is exactly what we're now going to dive into. Now, if I said to you, hey, can you tell me what the difference is, please, between these 3 IP addresses? You're probably going to go, well, hey, Jay, they're all the same, mate. I mean, they're all, well, I agree, they're all the same numbers in octets. But as an IP address is only as good as its subnet mask that's associated to it. So if I now said to you that this had a /8, that had a /16, and that had a /24, now they're definitely not the same. But hang on, now all of a sudden I'm also breaking another rule here. Because according to class-full rules, if an IP address is between 1 and 126, it's a class A. And if it's a class A, it's got a /8 IP address. So this one's correct, but then this one would be breaking the rule, and that one would be breaking the rule, and yes, that's exactly the point. We no longer have a class. According to the first octet, all 3 of these IP addresses are class A. But according to their subnet, that is a class A, that is a class B, and that is a class C. So which is it? Is it a class based on its first octet? Or is it a class based on its subnet? Well, it's neither. This is why it's now known as a classless address. Now, to make sure that you're absolutely confident and comfortable with what this all is based on, let me just break this up for you real quick to explain that the first IP address, 10, is the name of the network. The host is 123. So that means I have a network called 10, and inside that network, there is a host called 123. In this example, I have a network called 10.1. And inside a network called 10.1, I have a host called 2.3. Do you guys agree those are definitely not the same? Right, in the first scenario and the second scenario. And then in the third scenario, take that a step further, I have a network called 10.1.2. And inside of that, I have a host called 3. So you can clearly see that although the numbers were all the same initially, based on the fact that we're changing the subnet mask, can change the behavior of what the IP address actually means and how it's represented. And by changing that entirely, we now have classless addresses, and theoretically it means that we could reuse the same IP address, because I can use 10.1.2.3 and 10.1.2.3, and I could use this multiple times. Now you're probably looking at me at this point going, what is this guy on about? Why has he written it so many times? Well, now this is where the fun's really going to start. We're going to get into subnetting, probably in the next 2 videos. And in that, you're going to understand how things like this suddenly become possible. And now all of a sudden, we can use the same IP address, in theory. It's the same number, I agree. But now all of a sudden, we can start using totally different slash values for each one of them. So now I can have a /13, a /14, /15, and I could just keep on going down this line. So that means although the number looked the same initially, I can actually reuse this number in multiple places, multiple times, because the subnet mask and the IP address work hand in hand. They are not just, self-standing by themselves and that's it. They do work together. That is classless IP addresses, and it is what we use predominantly these days. So there's very few times where you will still see a classful address. However, routing protocols very often make decisions based on the classful aspect of a network. So, and once we get into routing protocols, you will get to see that firsthand. So that is video 4, nice short one for a change. Kicking off into the next video, we're going to be discussing what is RFC 1918. That is coming up in the next video. You guys know what to do. If you haven't subscribed to our channel, do so now, and we'll see you in video 5.